Prisms are sometimes found in glasses. Their primary role is generally to neutralize double vision. Unlike other lenses, prisms do not cause magnification or minification and are measured somewhat differently with a photometer. When you look through a prism, you will notice images will be displaced or shifted towards the apex of the prism. Light is instead deflected towards the base of the prism. As the photometer measures light, the green corona will always be displaced towards the base of the prism. If the green pinhole corona or focal lines cannot be centered on the reticule by adjusting the glasses on your lens table, then there is a prism present in the lens. In this example, you can clearly see that there is a sphere present, as noted by the circle of green dots on the reticule. The strength of this sphere is -5.75 on the diopter scale, as the corona is in focus at this power. There is also a prism present, as the green corona cannot be centered. The prism is measured by the amount of displacement it causes. Each marking on the reticule represents one prism diopter. In this case, the prism for the right eye lens is displaced by 3 prism diopters. In addition to recording the prism diopter strength, you also need to record the base position of the prism. As light is deflected towards the base of the prism, it will be deflected either inwards, towards the nose, outwards, towards the ear, upwards, towards the forehead, or downwards, towards the mouth. These base positions of prisms are recorded as base out, base in, base up, and base down, respectively. The position of the displaced corona will indicate the base position of the prism. In this example, we are using a base out prism with the right eye lens, hence the green corona is displaced outwards. Record your prescription, indicating the diopter power of the lens as determined from the diopter scale window, the value of the prism in prism diopters, and the base position of the prism. Now, let's measure the left eye lens. In this example, this lens also contains a prism, as noted by the displaced corona, which cannot be centered by moving the lens. The base in and base out positions are in different positions on the reticule for each eye. This is because the base in position is always towards the nose, and the base out position always towards the ear. So, the base in position for the left eye lens is actually a base out position for a right eye lens. You need to be careful of this type of lens orientation when measuring prisms. The base up and base down positions do not change for either eye lens. Therefore, in this example, we are using a base out prism with the left eye lens, hence the green corona is displaced outwards. Measure the left eye lens and record your final prescription. In summary, when measuring prisms, it is important to remember that a prism will deflect light towards the base of the prism. Each marking on the reticule represents one prism diopter. The base location of the prism must be recorded as either base in, base out, base up, or base down. The base in and base out positions are different for each eye lens.